Welcome to this explainer. Today, we're diving into a genuinely epic story. And no, we aren't talking about ancient empires or kings. We're talking about colliding continents, unimaginable forces, and the literal reshaping of the Earth beneath our feet. We're exploring the massive geological phenomenon known as the Siwalik Foreland Basin. When we think of the Himalayas, we naturally look up, right? We think of the highest peaks on the planet. But to truly understand the sheer power of these mountains, we actually have to look down.
6. That's a massive number here. The sediment thickness in the Siwalik Basin we're exploring today locally exceeds a staggering 5 to 6 kilometers. Just think about that for a second. We aren't talking about a shallow ditch or a little river valley. We are talking about a trench filled with up to 6 kilometers of solid rock and sediment. That is literally deeper than most of the world's oceans, sitting right there on dry land. The obvious mystery here is, how did a depression of this magnitude even get there, and what exactly filled it all up?
So this naturally brings us to the core question driving our explainer today. How on earth did the rising of the world's tallest mountains accidentally create a massive 6-kilometer-deep trench right next to them? I mean, it seems totally counterintuitive, right? You build a massive mountain upward, but somehow you end up bending the Earth downward to create this giant basin. Well, in the world of geology, every action has a massive landscape-altering reaction.
All right, let's get our bearings by defining exactly what we're looking at here. The Siwalik Foreland Basin is what geologists call a flexural foreland basin. It developed south of the Himalayas due to the violent collision between the Indian Plate and the Eurasian Plate. But the key word here is absolutely flexural. I want you to picture someone standing on the very edge of a diving board. What happens? The board bends downward under their weight, right? That is exactly what is happening to the Earth's crust here. The lithosphere is actually bending or flexing downward under the unimaginably enormous weight of the growing Himalayan mountains.
Section 1. The chronological epic. 5 steps to a basin. So, it all kicks off with step 1, the collision of plates. We're rewinding the clock back roughly 55 to 50 million years ago, abbreviated as MA for mega annum. The Indian Plate slams into the Eurasian Plate, initiating the Himalayan orogeny, which is just the fancy scientific term for this specific mountain-building event. Then comes step 2, crustal loading. As those Himalayas grew taller and heavier, their enormous weight caused the Indian lithosphere to flex downward, and that directly leads us to step 3. This downward flexure created a long, narrow depression immediately south of the Himalayas. That depression is the exact birth of the Siwalik Foreland Basin.
Okay. Let's move on to the final 2 steps to see how this builds into the landscape we actually know today. We've got our massive depression, right? But now it needs to be filled. Enter step 4, sediment supply. You have these rapidly rising Himalayas, which are immediately being attacked by the weather. Rivers begin eroding the mountains, acting like these massive, unstoppable conveyor belts, transporting huge volumes of sediments down into the basin. Finally, we hit step 5, the deposition of the Siwalik group. Between about 16 and 1 million years ago, an era spanning the Miocene to the Pleistocene, these rivers just continuously dumped thick successions of rocks and dirt. We're talking conglomerates, sandstones, mudstones, and siltstones, accumulating over millions of years, formally creating what geologists call the Siwalik group.
Section 2, the mechanical zoom-in.
Now let's peer beneath the surface to see how this tectonic domino effect actually works mechanically. Imagine the Indian Plate in the south, aggressively driving underneath or subducting below the Eurasian Plate to the north. When you picture that collision zone, you get that massive Himalayan uplift directly above it. But if you follow the Indian Plate backwards, away from the collision, you can visualize this massive downward curve in the crust. That right there is the flexure due to the mountain load. The sheer weight of those towering peaks is literally buckling the solid rock of the Indian Plate downward. It creates the perfect pocket, the Siwalik Foreland Basin, for rivers to deposit all those Himalayan sediments. It's just a perfectly balanced mechanical system of uplift and depression.
Moving right along to Section 3, basin characteristics and geography. Geographically speaking, this basin has an absolutely massive footprint. It essentially forms a long, sweeping arc right south of the Himalayan frontal thrust. If you trace the geography, you'll see it extends all the way from Pakistan in the west, stretching right through India and Nepal, and ending over in Bhutan in the east. It's a continuous border hugging the southern edge of the mountains, specifically sitting south of the major fault line known as the Main Himalayan Thrust, or MHT.
So what's actually inside this massive geographical footprint?
Well, let's get into the hard data. The age of the rocks here ranges from the Miocene to the Pleistocene epoch. Again, that's roughly 16 to 1 million years ago. The depositional environment is entirely fluvial, which is a fancy way of saying river-based. This whole area was defined by sprawling braided rivers and vast alluvial plains. And because it was a river system, the main sediments laid down were fluvial conglomerates, which are essentially like a natural concrete made of gravel and pebbles, along with sandstones, siltstones, and mudstones. We are talking about millions of years of river mud and rock piled up to 6 kilometers high. It's like imagining a skyscraper of gravel stretching into the clouds, except it's buried entirely beneath your feet.
Which brings us to Section 4, Essential Geological Takeaways.
First up, we need to bust a very common misconception. It's absolutely crucial to know the difference in classification here. The Siwalik Basin is definitively a Flexural Foreland Basin. It formed due to the lithospheric flexure caused by the Himalayan loading we've been discussing. It is definitely not a rift basin. A rift basin happens when tectonic plates are actively pulling apart from one another to create a valley. But in our case, the plates are violently smashing together. The basin is just a side effect of the crushing weight of the resulting mountains, not plates tearing apart.
Our second major takeaway is all about the timeline of the rock itself. The Siwalik group we've been examining represents the youngest major sedimentary sequence associated with the entire Himalayan orogeny. Because these sediments are derived predominantly from the active, ongoing erosion of the rising mountains, this basin represents the most recent chapter in the geological record of this massive collision. The rocks here are, essentially, the freshly ground sawdust left over from the ongoing construction project that is the Himalayas.
And that brings us to a final, kind of provocative thought to wrap up this explainer. We just called it the most recent chapter, but guess what? The book isn't finished. The Indian Plate is still moving north, the Himalayas are still being pushed up, and those rivers are still relentlessly eroding them down. So if these tectonic plates are still moving and the mountains are still eroding today, what will this continuously changing 6-kilometer deep basin look like millions of years from now? Is it going to flex even deeper? Will it fill up completely and spill over? The Earth is an active, incredibly dynamic machine, and the Siwalik Basin is ultimate proof that the ground beneath us is anything but permanent. Thanks for joining me, and keep questioning the ground you walk on.